right, let's finish up that thought. So we were saying that we can add this one over and add that one over. And so then what we're left with is momentum final of A plus momentum final of B will equal momentum initial of A plus momentum initial of B. So we have all of our initials together and our finals together, and they're added. So we could say the sum of the momentum's final will equal the sum of the momentum's initial. So that's our conservation of momentum. What we ended with is what we started with, or what we started with is what we ended with. Okay, so we're going to take this idea and we're going to apply it on some practice problems. 1,875 kilogram car going 23 meters per second rear ends a 1,025 kilogram car going 17 meters per second on an icy road going the same direction. The two cars stick together. How fast do the two cars move together immediately after the collision? Right? So rear ends it makes me think that we are going the same direction. Right? That we had one vehicle slam into the other, but that the initial velocities are both in the same direction, and we can call that direction positive. Okay, so we have two vehicles. Well, we call them A and B, and so car A has a mass, so mass of A will be 1,875 kilograms. Mass of B, so I'm going to see if I raise this up a little bit more, if we have less of that focusing issue. Okay, we'll see. So we have car A and then car B. 1,025 kilograms. And then we have these velocities, they're both positive, right? So the initial velocity of car A is a positive 23 meters per second, and the initial velocity of B is 17 meters per second. Okay. So that's our initial conditions. The two cars stick together. How fast do the two cars move together immediately after the collision? Right. So we should address is that the fact that they stick together. Okay. That we start with this. This is our initial condition. Okay. And then our final condition is something like that, right? Where this is A and B. Okay, so they stick together, and so now in a final component, it's not mass of them individually, it's the mass of A plus B, right? It's them added together. So let's do that. Let's take those two numbers, let's add them together. So 1,875 plus 1,025. Oh, yeah, I should have seen that. So 2,900 kilograms. Okay, so we're going to treat it as one object on the other end because they stuck together. So this is our initial, this is our final. Our velocity final of this AB all together, that's what we're looking for. That's what we want to know. Okay. Now, we've shown that whatever we start with momentum-wise, the sum of the momentum's initial are going to equal the sum of the momentum's final. Okay, and initially we have these two objects, and so we would have momentum initial of A plus momentum initial of B, and that would equal momentum of this AB combined final, right? Because we only have the one object in the end, and so we only have the one momentum. And then we can break that down. We know that momentum in general is mass times by velocity, right? So this would be mass of A, velocity initial of A, plus mass of B, velocity initial of B. And that's going to equal mass of AB, right, that combined, multiplied by that velocity final of that combined. This is what we're solving for. We know everything else. Multiplied, so let's divide that over. So mass of A, velocity initial of A, plus mass of B, velocity initial of B, divided by the mass of AB will equal that final velocity of the combined stuck together items. Okay, so on the top of the fraction, we have mass of A multiplied by the velocity and added that to mass of B multiplied by the velocity. That's the top of the fraction divided by the bottom, which was the mass of them combined. Okay, so the object combined has a final velocity. What were we dealing with here? 2 sig figs of 21 meters per second. Now let's ask ourselves, is that reasonable? We had one car going faster than that, one car going slower than that, but then they collided together, and so their final velocity was something in between. Yeah, that seems reasonable. Right. So that was number 6. Number 7, we have the same situation. The two cars stick together. How fast do the two cars move together immediately? It's just the same. Oh, opposite directions. Now they're going opposite directions. Instead of them going the same, like rear end going the same direction, they're going opposite. And then they stick together. Okay, that works. So let's check that out. So what's happening here? Car A having, we'll say, a head-on with car B. Okay, so this is what's going on initially, and so our mass of A is the 1,875. The velocity initial, because I drew it going this way, I'll call that my positive. So that'll be a positive 23 meters per second. And then mass B is 1,025 kilograms. Velocity initial of B is a negative 17 meters per second because it's headed in the opposite direction. And so now we have our final component here, okay, where we have one object, so the mass of AB, which was 2,900 kilograms, and again we're looking for that final velocity there of the combined object. Okay. Let's look at this really quick. What we started with is what we're ending with. Okay, and so it'll be the initial conditions will equal the final, right? That whatever this momentum is, positive or negative, it's going to be added to whatever that momentum is, positive or negative, because that's the initial conditions. And then that's going to have to equal the momentum of the final, the one object. And so we're going to plug this in the exact same way. Where you haven't accounted for that negative sign, that'll go in when we plug the numbers in, right? And so we have momentum, and dividing over. We end with the same thing is what I'm getting at, is we've solved for this symbolically, and the only thing we've changed is that instead of it being a positive 17, it's now a negative. Okay. So what we ended with before, mass of A, velocity initial of A, plus mass of B, velocity initial of B, divided by mass of them combined, will equal the velocity final of them combined. I even still have it up in my calculator here, except now it's not a positive 17, it's a negative. And so the final velocity is 8.9 meters per second. Okay, now let's ask ourselves, is this reasonable? We have cars of somewhat similar mass headed in opposite directions, but this one's a little bit bigger and it was going a little bit faster. And so when they collide, the whole thing significantly slows down, but it still is headed in the positive velocity direction. They hit, and then but this whole mass is still, headed that way. Yeah, I think that's reasonable. Nice. Okay, what are we at time-wise? Okay, so we're going to talk about recoil, and then we just have one more example and then our last little kind of summary for today. So what's going on, what's happening as far as momentum goes and conservation of momentum when we're firing a rifle or a gun? Okay? We have a bullet and we have the gun. So those are two objects. And when the bullet is loaded into the gun, then we can call that one object, right? The mass of the gun plus the bullet, like when the cars were combined. And so our initial momentums would be our initial momentum of the gun or the rifle plus the initial momentum of the bullet. But they're not moving anywhere, right? The velocity of both of them is 0. And so that's 0, so combined they equal 0. So when the gun is fired, oh, that's better. When the gun is fired, what happens is we get an explosion, and it's this idea that we started as one and we became two or more items, okay? And so now the bullet has a velocity and the rifle has a velocity, and we know from Newton's third law of pairs that the force of the gun on the bullet has to be equal in magnitude but opposite in direction to the force of the bullet on the gun. Now that doesn't mean that their accelerations are the same, but it does mean that the force is the same. We have this mass component that comes in. Okay? We have conservation of momentum as well. So if this is what we're starting with, the sum of the momentum initial has to equal the sum of the momentum final. And so if those are equal to each other and this is equal to 0, then the sum of momentum final must also equal 0. And then we'll break that up. That the mass of the gun or the rifle multiplied by that final velocity plus mass of the bullet multiplied by the final velocity must equal 0. Okay?